third droidCon. This is a third droidCon online event. I was just realized I'm repeating myself because I forgot to push the start button just a minute ago. So this is the third installment. Our first one, if you joined us last month, was our Jetpack, our first Jetpack series. We had our Advanced Scotland series, and now we're doing our Multiplatform series. This one is going to be dedicated exclusively to Kotlin Multiplatform. We're excited today to have Carlos Mota with us here, and we also have Russell Wolf from TouchLab. It's going to be actually really good webinar today. It seems, I was thinking about this today that Kotlin Multiplatform, this was released this was a part of the 1.2 release in November of 2017. And it seems like, I was thinking about this, it seems like we haven't been talking about it as long, but it's been around. And in fact, I was realizing today that, Russell, I went to your presentation in droidCon at droidCon New York in 2018. So I'd be interested, we should talk about that too, in the beginning, how different this presentation is today than it was when you delivered that in 2018. But that's for another time. So we have, again, first up, Carlos, and then Russell. A couple of housekeeping issues. We'd love for everybody who has joined us right now to open up, to go to slido.com, open up a separate window. We use Slido to manage our Q&A. This helps us to make sure that in the 10 plus minutes or so that we have for Q&A, that we're able to get through this in the most efficient manner. If you haven't used Slido, it's really easy. You'll see a list of questions, and what we suggest is before typing in your own question, take a look at the questions that have already been asked and vote on those up or down. If you think it's an important question, if you think it's the same question that you were going to ask, vote up or down. And what that allows us to do is then, as soon as our speakers are done, they will be able to get a list of questions presented to them, and they'll be able to answer then the ones that are most urgent, that are most popular, that were most asked. So take a look, and then throughout the webinar, if you miss the slido.com and the code that's presented here, 44415, Uli, one of our co-organizers here, will be presenting that as a link, as a unique URL in the chat feature. So take a look at your chat window as well. For that link, and periodically throughout the webinar, we might send out some links, whether it's to individual slides or some materials from the presenters. Just to give you a quick tease on what's coming up, just so you know, all the videos from today's webinar will be available within the next day or two on droidcon.com, fully transcripted and searchable, so you should have that. So check back regularly at droidcon.com. If you've missed any of the other webinars in the droidCon online series and you're interested in seeing what we've done thus far, you can always go there and find the last two videos. Again, a little teaser about what's coming up. On May 28th, this is a little bit of a change from what's online, and I'll be updating that later today. We'll be replacing our in-depth hands-on webinar with another Advanced Kotlin series, our part 2 of that, and that information will be online shortly. So with that, no further ado, I want to have Carlos Mota. We're going to have him come into the stage here as well, his screen, and we'll be able to share his. And he should be coming online shortly. Carlos, would you like to get your camera on? And I'm going to pop out, and the time is yours, Carlos. Thanks.
Hello, everyone. Let me you're all seeing my screen, right? Let me just open the chat here. Okay, nice. So is everyone hearing me well? Can you see the slides? The people on the back can hear.
You're all good, Carlos. You're all good.
Yes?
We can see and hear you.
Let me just, what? So let's start. I truly hope everyone is safe. For me, it's truly a pleasure to be here and to have a sense of reality with this droidCon online series. I want to thank you all for being here, and I've selected this picture as my first screen because it's how I hope everyone is watching this talk. They are all safe and comfy at home. I decided to wear a suit because why not? The first time I'm doing it. But don't worry, I'm just wearing a shirt and a tie. I'm still on my tracksuits below, so don't worry on that. I'm still comfy. Hello, my name is Carlos Mota. I'm from Portugal, from Coimbra, and I've been developing for Android for the past 9 years. And for the past 1.5, 2 years, I've been playing a lot with Kotlin multi-platform. You can find me on Twitter at @cfonsmota. I've put the slides there. I usually tweet about Kotlin Android and about photographies and traveling, and now from my living room, so you can only find pictures from home. These slides are also available on the chat, and you can find them on my Twitter or on my speaker deck. I have some code here, so if you want to follow them on the speaker deck, please be free to follow it. So I'm guessing that most of you are Android developers, right? I'm also betting that someone here will also be developing for iOS or even the web or even backend. Probably have people developing for server side. And there is a really cool thing about Kotlin here, because you can have Kotlin on all of these platforms. Let's start. I really love this image because I was searching for image with laptops and programming, and I noticed if you look at the bottom corner of this picture that you have a nail and someone is programming PHP. Not sure if related, but let's assume there it is. Let's imagine that we have a wild application idea and we want to develop it for Android and for iOS. So basically, you will hire a team of specialized developers. You're going to define requirements, design mockups for both platforms, and please do this. It's really important that we don't have an Android application look like an iOS application and vice versa. You will need to plan the features development, start development, writing unit tests, and cross-checking validation between both platforms to guarantee that everything is working as expected and you have the same behavior on both platforms. So this roughly also means that you're going to have 2 times the team, the cost, the status meetings required, probably a bit more than 2 times, but who's counting? The time spent on development, the time spent on testing, the time spent on bug fixing. And if we then decided to also develop for the web, we're going to have 3 times the team, the cost, the status meetings required, time spent on development, testing, and bug fixing. So what we really want is to cut this on half. So let's try to find a solution that works on all platforms. And we've been trying it since 2006, when PhoneGap initially appeared. And we've seen a lot of solutions here. We've seen Xamarin, Rubymotion, Ionic, NativeScript. We've seen Kotlin Multiplatform and Flutter more recently. And I'm going to talk a bit about the advantages of cross-platform solutions. And you'll see that I'm not putting Kotlin Multiplatform here because it's not a really cross-platform solution, as you're going to see in further detail in some slides. So typically, if you're doing cross-platform, using a cross-platform framework, you're going to need a smaller team. You don't need to have 2 teams, you just need 1. Typically, it's half the cost of doing it natively, and if your company already has a set of web developers, the small learning curve from coming to the web to mobile using one of these frameworks, it's quite small. Probably if you're using Flutter, it will be a bit higher, since Dart it's not a really familiar language, at least for now. I'm going to speak also about the disadvantage here, and before I start talking about them, I want to say that disadvantages are common disadvantage of doing cross-platform solutions, of using them. But in the end, what matters is what makes sense for your project, for your company. If you have a short budget, if you only have people from the web, it might make sense for you to use one of these platforms. So typically, one of the worst parts of using one of these solutions is that you're chained to the framework implementation of the UI. This means that every time a new OS is launched, and if there is a big redesign on the OS, you'll need to wait for the people from the framework to develop these new widgets, to update them. And I had this problem a few years ago with a Xamarin application, that there was a big redesign on iOS, and my application for 5 months still looked like the one with the previous iOS, because the people from Xamarin took some time to update these widgets. And once this update was released, I had to compile the app once again and then submit it to the store. Only at that time my users were able to see the look of a recent update of the new OS. And it's important to mention here that on iOS, when you update from one operating system to the other, the numbers are roughly 80%, so 80 of the users will update to the newest OS on the upcoming week. So all of these users needed to wait 5 months until an update of that version was released. Performance is not the same. Okay, I know there is a huge debatable on this, but it's not. There is some not native components that might need to be written. Sometimes there is no full support on the framework side. In case of Flutter, Dart, it's not a widely used language, at least for now. And a really important point here is that you're committing all your project to one framework and to one language, meaning that if you're doing a project that's going to be developed for the past 10 years, you need to take into account that during those 10 years, the framework needs to exist. Otherwise, what will happen? You will need to migrate your project to the other framework. You will need to develop the framework yourself. These are really risky decisions that you need to take into account before selecting one of these advantages, one of these solutions. So how can we have the best of both worlds? I think you all know the answer now. Kotlin. Every time I talk about Kotlin, I always love to show a small video, so bear with me for the next 30 seconds.
Tyle keczupu Kotlin zmieści się na frytce. Tyle na kanapce. Tyle na burgerku. A tyle na żeberkach. O, a na szaszłyczku jeszcze więcej. Nie ma konserwantów, nie ma ograniczeń. Jesz tyle, ile się zmieści. Kotlin. I love ketchup.
Exactly right. We all love Kotlin, right? Fun fact, now searching for this clip, it takes a while. Kotlin is so popular that you really need to search for Kotlin Ketchup to find it. So we all know Kotlin. It was developed by JetBrains. It's open source, it's concise, safe, interoperable, tool-friendly. It's supported and is used by Google. And Google says that everything that they're shipping now for Android in apps, they are doing it on Kotlin. And what some people forget is that it's more than just for Android. You've got Kotlin on server side, you've got Kotlin.js, and you have it native. I could be speaking about Kotlin the entire talk and even more. These are just some of the few features that all of us use daily. We have mutability, null safety, collection, step inference, and a really important one, it's easy to learn. And this is really important on multi-platform, especially if you're targeting mobile, because there is a really small learning curve involved if you're going from Swift or JavaScript into Kotlin and back. Swift and Kotlin are really similar languages. Let's see a quick example. For instance, on Kotlin, if you want to define a variable, we call it a var, a mutable one. If we're going to define a mutable variable field, we call it value. On Swift, it's the exact same thing, but instead of val, we're going to use let. If you now go to functions, on Kotlin, we call it fun because we have fun. I bet no one ever made this joke. On Swift, we call it func. There are also a few differences. In string interpolation, you use the $sign in Kotlin. On Swift, you use the slash with parentheses, and when the return type, use 2 points, while on Swift, use the arrow. Creating an object, accessing that methods on that object, it's the exact same thing. So let's talk about Kotlin multi-platform and what is Kotlin multi-platform. So it's when you use Kotlin in projects that target more than one platform, right? Easy. Let's see this example. We want to develop an application for Android, for iOS, for the web, and a desktop. So typically, our application will have a presentation layer. We'll also have the model, the parser, the network, and then we're going to implement the views. How can we interact with those presentation and with all the options? And then we're going to do the exact same thing for iOS, for the web, and for the desktop. And there is a part, what we are going to call the business logic, that we are doing over and over and over again. What you're going to change, it's the libraries that you're using. So what we really want to do here is just to merge everything and use a common model that will allow our views to access all this information. So Kotlin multi-platform, it's not focused on sharing the entire code, it's just focused on sharing the logic, the application logic, and leave the UI to the native implementation. So you're going to still do your UI on Kotlin in case of Android and on Swift in case of iOS. There are a lot of advantage on using Kotlin multi-platform. First, you're doing it on Kotlin. Also, there is a really low risk here. You can decide what you're going to share across all platforms. You can start by sharing tests, for instance. You can start by sharing your network, your database, an image processing library. You can decide what it's worth to share. And as you see that it's working on our project, you can increment this and share even more models. So you decide which risk you want to take on this approach. It's interoperable, and you have really consistency across platforms. So you're designing and developing this shared model, and you're going to use all your business logic in all the platforms. So this means that all the platforms will behave the same way. Also, and a really important point here, you have a really strong community support. The Kotlin Lang Slack is amazing. I've asked there hundreds of questions, and typically in 1 or 2 hours, I have an answer to my problem and I can move on coding other features. So I'm guessing that you're all like really excited, right? Yeah. So let's see how can we communicate. So if you're developing a C++ library, for instance, that could also be used to share code across different projects, on most of these libraries, typically what people do is having if-else throughout the code. If you need something from your platform, from iOS, you're going to use this. If it's from Android, you're going to use that. And this is typically how most of those libraries work. Kotlin multi-platform, it's way different, and it works really, really cool. So how can we expect to communicate and to access platform-specific values? The answer is quite simple. We use the keyword expect declared on a common model, and then we use the keyword actual when you want to define something that is platform-specific. Let's see an example. We want a platform-specific value for a name. For instance, we have an application, and we want on Android to say hello Android, and we want on iOS to see hello iOS. So this name needs to be platform specific. So what we're going to do is to use that keyword expect, and if you look at the top bottom corner of the screen, you see that this is being defined on a model called common main. All your shared code is going to be on common main. So I'm expecting that someone will say what name is. So if I'm targeting Android and iOS, I need to define actual on both of these platforms. So I'm going to use here, and if you look once again to the bottom of the screen, you will see that I'm using Android main to define the name for this field on Android, which will be Android, and in iOS, I'm going to define name as iOS. If you look at the IDE, what we're going to write, expect object, the IDE already does everything for us. So we're targeting Android and iOS, and you'll automatically say, okay, you're targeting these platforms and you don't have this defined, so just press Alt Enter and it automatically create everything for you. When you try to create your first project on multi-platform, sometimes it's not as direct as one might expect. You have to make some changes. I've written and updated that blog post, so if you can find it on my Medium, you still have to make a few changes, but you can have a project running in no time. There is also a collection of code and tools designed by JetBrains and TouchLab that help you start with your first project. It's called CampKit, and it's an excellent starting point. You can find all these links on my last slide, so you can start coding multi-platform in no time. So I've been talking about multi-platform. Now let's see a demo application and some code. So ready. This is a project that I've done for droidCon Madrid to present this use case there. It's a conference application. So you can find this on my GitHub, cmota/droidCon Madrid. And you can find the project here. So as I was mentioning, you've got Android main, common main, iOS main. and we're going to see the dispatchers. This needs to be platform specific. So I will need to define this on the Android and iOS. So if you go to Android main, you'll see that I've defined them here. And now we can navigate to the iOS main to see them defined on the iOS side. As you can see, everything is inside IntelliJ. I also needed to define HTTP client, a database engine, and everything once again is defined on iOS main and Android main. For database, I'm using SQLite, so I needed to write the SQL instructions. And then I have my common Android code, all the Android libraries that I'm using on Android main. So this is an activity, and here is a fragment containing the favorites or the favorite talks. So I only needed to implement the UI on Android because it's just using this common model, and it's fairly simple. I have a recycler view. I'm searching for my talk for myself. I believe I'm going to like my own talk because why not? And then I'm accessing the list of speakers. I'm using Glide to retrieve the speaker's image, and I have information about the venue. You're already familiar with the build folder. Now, when you generate the framework that's going to be used by iOS, it will also have a bin/iOS folder. This framework is going to be imported on the Xcode, or you can use AppCode if you want, and it will contain your command model. Okay, you're going to access the command model through this framework. Once again, you can keep programming in iOS using Swift and using all the libraries that we are already familiar with. Here, I'm also using CocoaPods that was easier to allow me to manage my dependencies, and I only needed to implement here the UI. I'm also going to like my own talk. It's worth to mention that I'm no iOS developer, so if you're looking at this code and if it's something on Swift it's not quite as it should be, please be free to make a merge request that I will accept it in no time, so don't worry there. So the project is really simple. I have a recycler view in Android, a white table view control on iOS. I'm making multiple network requests to Sessionize API. I parse these response objects, I sort them locally, as well as the favorite talks. And then I notify the UI when there's new content available to be drawn, and I reload the list. So typically, these are the libraries that you're going to use on Android, on iOS if you're doing everything native. So use Room for Database, and you use Core Data, use Retrofit, Alarmfire, Gaze, and JSON serialization, RxJava, RxSwift. And the big difference here is that you're going to use activities on Android and UI table view and UI view controller and UI table view in case of iOS. So there is an unnecessary duplication of code. All your business logic could be just done once and imported for both platforms. So instead of using Room and Core Data, you could use SQLite, Ktor, Kotlin externalization, coroutines, and tests. So this is a really high-level diagram of this application. So I'm using, once again, Ktor for my network requests and SQLite for the database. I'm going to use my model of objects, and then I will have get, schedule, and speakers to access these upper layers. And then we're going to define this platform-specific HTTP client, SQL driver, and dispatcher. This is the code that will depend on the platform itself. And then the views, the activities are going to be done on Android and then on iOS. So let's start by seeing the code. Once again, this is all available on my GitHub, so feel free to check them there. We're going to define this on the shared model. So we're going to use the command main for this. This is where all your shared code is. So we're going to receive an engine, this HTTP client engine that will be defined on platform specific. And we're going to see this on a couple of slides. And we have a URL for the Sessionize API. So what we're going to do is just create our HTTP client and make a get to that URL. We're going to use Kotlin X serializer just to parse this response, this JSON response, and have a list of speakers, a list of objects that contain all the information related with speakers. If you're already familiar with Android, that I'm guessing that almost all of you are, This is already what we used to do on retrofit. So we've got a response here. We have the fields for ID, first name, last name, full name, etc. We just create a class, speaker entity, and use the annotation serializable, and then we'll receive this list when we make the request. This data will then be stored on a database. I'm going to use SQLite for this. You'll need to write the instruction, and SQLite works a bit different from most libraries, so you need to write the SQL code. And what will happen next is that they will compile this instruction and generate the code that we're going to see here. That is, this insert or replace speaker will automatically be created by the SQLite. Still on the command main, I'm going to create just a simple speaker DAO to access this data. You'll see that I receive a speaker object. I'm just going to use the ID to identify the speaker itself, but then I'm just going to add it as a JSON object, as a string on the database to keep things simple, and create a get all speakers just to retrieve the list of speakers. We're also going to simplify the speaker object because having a speaker entity has a lot of information that we don't need. So we're just going to create a speaker that has just 6-7 fields that contains all the information that I need to show this information on the UI. So let's see these get speakers and how this works. So I'm going to receive here an API, a sessionized API, and a DAO that is going to store this data on my database. So as the first code that we saw, we had a fetch speakers, right? So we're going to call the sessionized API.fetch speakers, and we'll receive the result here. After this, we're going to have these speaker entities that we received and to map them to the speaker object and insert them on my data access object, on my database. If this operation success, we're going to just call on success. If it fails, we're going to call on failure. Now let's reach the presenter class. I'm going to create here a method called attachView. I could have called any other name. I call it attachView because I was going to call it on create or on view did load in case of iOS. And we're going to receive an interface here. This interface is iSpeakers data. It's how we're going to communicate with the UI. So when you call attachView, you need to send this interface. This interface is really simple. I'm going to have just two methods. On speakers data fetch that contains the list of speakers, and on speakers data file just to notify that it wasn't possible to receive the speakers. Once I receive this view, I'm going to call fetch speakers list, and that on success and the one failure method that I've shown you before, it's just going to call this view on speakers data fetch or view dot on speakers data file in case this operation fails. Going to the service locator, you'll see that we have a get speakers presenter. So this is the method that's going to be called from the UI, from the presenter on the UI side. And what it's going to do is just to initialize the sessionized API in speaker DAO via these get speakers. And now if you look at these two, sessionize and speaker DAO, you'll see that they access the platform service locator. Typically, we use the keyword platform when you want to access something that is platform specific. In this case, the HTTP client engine and the database engine. So are you all with me, right? So I told you before, in order to have something that is defined by the platform itself, you need to use the expect and then the actual on Android main and the on iOS main. So on our common model, we're going to say that we expect someone will define what HTTP client and database engine is. So if we're saying this, we need to define this on the Android. So on Android main, I'm going to say that I'm going to use for the HTTP client engine, OK HTTP. And for the database engine, it's going to use Android SQL driver. And on iOS main, it's going to use iOS create and native SQL driver. So I say that I expect someone that will define this. And once again, on Android main and the iOS main, I say that, okay, actually, this value means this. Now that we have everything defined, we can now go to the UI part, and let's go to common Android and access that service location.get speakers. So once we access this method, we can call attach view that, as we saw before, it will trigger the fetch speakers. And once this data is available on speakers data fetch, it's called automatically with a list of speakers. We'll then populate the recycler view with our adapter, and we can still keep using everything that you're already familiar with. You can keep using our libraries. You're doing things native as you're already familiar with. Now, if you go to the iOS part, we go to iOS app. We do the exact same thing. We call the presenter attach view, receive the list of speakers, and then we update our views with this list of speakers. So I'm guessing the big question that we have is how much sharing should we do on multi-platform? Honestly, it's what makes sense on your app. Some quick conclusions. This slide is from last Kotlin Conf, because this question on how much it's worth sharing, we've seen it a couple of times, and it depends a lot on your application. For instance, JetBrains announced its space, and they said that it was full Kotlin multi-platform. Everything is done on Kotlin multi-platform. Cash App, for instance, decided that they are only sharing their business logic. Yandex Maps is sharing their business logic, wrappers for C++ libraries. Planboard is sharing business logic, networking, offline caching layers. So it's what keeps sense on your application that you should share. It's also worth to mention that all of these applications are already on production. So although multi-platform is still on its experimental state, still on experimental phase, we start to see several projects on production. Since it's still on the experimental state, this means that sometimes you update a library and you break one of your builds. This is especially true when you want to also target, for instance, the web. I had a couple of projects that I was testing to see how could I have everything with web and desktop, and every time I made an update in one library, I usually ended up breaking the web part. Once again, the community is really, really good, and you ask on Kotlin Slack what I was doing wrong, and they're more than fast to answer to your questions. A small advice: start small. Don't try to reach 100% of shared logic. This is really important. Don't start to move everything to Kotlin multi-platform. Don't stop creating features just to move everything for multi-platform for the next 6 months. Start small, see how your team is going to adapt. Your team is going to change if you have things on multi-platform. You need to take care of the iOS team. Start one model at a time. Start by network, database, image processing, small modules that will give you extra confidence to continue moving things to multi-platform. I mentioned iOS team because, well, from their side, this means that you're going to start to have code that was typically on Swift, to start having that on a common model, on the framework that they are going to import. From my experience, people on the iOS side, they didn't saw any problem with that, because they could focus on just doing front end and not caring about what was happening on the back end, let's say. Also, it's worth to mention that using Kotlin multi-platform still means that they are going to do the UI using Swift, and if you're using Flutter, this stops. So it's also a good approach on convincing them to multi-platform instead of other cross-platform solutions. We had a big problem when you're programming for iOS 1.5 years ago, because it was really tricky and it was almost impossible to debug it from the iOS side. Fortunately, the people from TouchLab created a plugin to allow you just this, and during the last Kotlin Conf, official support was mentioned that it's going to be released somewhere this year. Some final conclusions. Once again, the community is really, really strong. It's growing a lot. A lot of people are already using Kotlin. A lot of people are starting to use Kotlin multi-platform. Google and JetBrains are pushing Kotlin. It's 2 times faster to develop your features business logic, 2 times faster writing unit tests, and the biggest point here, it's one tech stack. You've got consistency across platforms. Being said, it's also important to mention that if you put a bug, you have a bug on both platforms. But a really cool thing here, and let's see the cup as half full. If you fix a bug, we're going to fix a bug on both platforms. So here we go. A couple of libraries, really good libraries that are out there: Ktor, Kotlin-X, Coroutines, Serialization, SQL Delight, multi-platform settings, Hello Russell. is going to speak afterward, and he was one of the authors of Multiplatform Settings, and we've got Stately. I've got here also some links of some cool projects to follow. Once again, you can just access these links. The slides are already available. Some more useful information. You've got the Kotlin Slack, the Kotlin official. You have a lot of talks from Jake Ward. You have the people from Touch Lab. They're also writing, and they released a book, if I'm not mistaken, a few days ago. It's really, really good. And of course, you have all the Kotlin Conf videos. So thank you for assisting to my talk. Let's see how many questions do you have now.
Great. So excellent job, Carlos. We're always we're always trying to improve our attendee speaker feedback. So version 1.0 was the Bravo app where you can get the clap. So now we're going to introduce let's see here, version 2 of our interaction. Let me see if I can get that over here. Let's see here. Hold on, before we start with the questions, I gotta do this one here.
Okay, let me just see.
Okay,
okay, I'm here.
Can you see now the screen? This is a representative audience.
Full room, nice. Oh, thank you. I can now finally take my jacket and my tie. This was a really bad decision.
And I more clapping. So, and I also have to say, the outfit did get a shout out from my guy Nicola Corti. Gave you a 1+ on the outfit choice today. Haven't seen Nicola since droidCon Lisbon 2019, but anyway, so you did get a shout out on the outfit as well. So
thank you.
Anyway, so great job here. Let me get Uli here back up online so that we can show the questions, and the time is yours on the questions.
Okay, let's start by a difficult question. When it's going to be ready for production? Well, I would say that probably still going to have it experimental another year. They're making a lot of good improvements. It was released, if I'm not mistaken, yesterday or 2 days ago, version M2 version for Kotlin that have a lot of improvements on multi-platforms, especially for the second question, that is when Kotlin coroutines supports multi-threading on iOS. According to the issue on the GitHub, it should be available on this next Kotlin release that happened 2 days ago. So answering both questions, so I'm hopefully it's going to be ready after 1 year, but let's see. They launched Spaces, which is full Kotlin multi-platform, so it's almost there, I would say. And support for multi-threading. Let's see this new version, because I believe that they are going to have this support now. So is Kotlin multi-platform ready to go to production apps? Yes, we already have a couple of apps on production. Cache App as the business logic, IndexMap as business logic, and a few more things. And there are available libraries available for netcalls. Yes, we have Ktor that's already available. I've been using it, so I've made a switch from Retrofit to Ktor, but it's available and it's working pretty good. So how about dependency injection? So I think there are already some dependency injections libraries that work. For instance, if I'm not mistaken, Coding works, and you can use it. And I think there is a new one called Injection. I haven't used this one, but I read a blog post and it looked pretty good. What are the benefits of using expect actual versus plain interfaces? Well, you can do a lot of things with expect actual. You can use construction, you can have methods, you can do everything, almost everything that you want, that you were limited in using interfaces. Can you use Room with multi-platform? Well, you can use it on the Android side only. You can't use it on the multi-platform side, so you'll need to use SQL Delight, for instance. Is there a reason why I use MVP, or is it possible to use MVVM as well? It's possible to use MVVM as well. Yes, I used MVP more because I'm more used to it, to be honest. What are the cons of using Kotlin multi-platform? The first one, it's experimental. The second one, since it's experimental, well, it's still being developed. For instance, suspend functions, it's going to be available only now for iOS. So it's still a work in progress. What's your experience with shared code in terms of instrumented UI tests on Android, iOS? I've only done unit tests on multi-platform, so I cannot really answer to this question. I'm going to make some tests and I will reply in a tweet on the upcoming days, I promise. With Kotlin multi-platform, is there a need to obfuscate code for more sensitive apps? Yes. Well, your code still needs to be obfuscated, but you can still use ProGuard for that. And in case of iOS, if I'm not mistaken, it will be assembled, so there is no need to obfuscate because the platform already does that for you. Can you detail how to set up the common Kotlin model in Xcode? Yes. So I have a blog post about this on Medium. It has all the details there, along with some screenshots. Basically, what you do is from your IntelliJ, you're going to have a method where the framework is going to be generated. You compile the project, and under build/iOS/bin, you're going to have the framework there, a debug framework and a release framework. From your Xcode side, you just need to import this framework and use it as you would use any other framework. So, okay, sorry. Is it possible to move Android resources to Kotlin multi-platform? I believe, I would say that no, but honestly, I haven't tested this, so it might there be any solution that I'm not aware of. Can we adopt the Kotlin multi-platform gradually, model by model, into an existing massive app? Yes, and please do that way. Don't start to do everything on multi-platform for the next 6 months. Don't try to do it. So start small. Start on small models and see how it is going to evolve. Is there going to be any support from Firebase Firestore for Kotlin multi-platform? I would say yes, probably on the upcoming months. How does interaction between an iOS framework important for Kotlin multi-platform using C-interop, CocoaPods plugin, original framework in Xcode work? I would say that the behavior it would be practically the same. It's I honestly only use the framework imported by myself. I haven't tried to use it on a CocoaPods, but I would say that it's the same behavior. It's a framework that you can just import. It should be quite similar. How often did you face an issue with campaign? Honestly, to solve an issue with Kotlin multi-platform, I usually don't go to Stack Overflow. I go to Kotlin Slack. It works way faster, and typically, probably 50% of the times, by just searching for my error, someone has it. Also, not only the Kotlin Linux Slack, but if you go to the GitHub and you search for an issue, most of the times someone already asked that question. So most of the times you also have a workaround. Would it be possible to call async code from multi-platform mode without callbacks in a routines way, but from iOS? Well, it's going to be possible. It's not quite possible now. There are a few workarounds, but there is still no final solution. Hopefully, after this latest release, it's going to be possible to do it. How can we?
Carlos, let's take one more question, Carlos, okay? We'll take one more.
Do you have any concerns about App Store rejections? Honestly, I don't have. Usually what happens is when you have an App Store, the people from Apple don't like if you have any reference to Android, but having a framework that you're just going to import I don't see any problem with that. It's also worth to mention that this already happens when you have C++ libraries. So if Apple has never, at least that I'm aware, rejected one of application because you're using a C++ library, it's not going to use it on a multi-platform project. At least it's what I'm expecting.
Great. Carlos, thanks so much for being with us here today. It was really fantastic. It was good to see you. Thanks for joining us. You looked great too. The suit was a huge hit, as we know. This is fantastic. So thanks for being here. I hope you'll stay online. There's going to be for Russell's presentation, it's going to be great. In fact, I'm going to switch him over here to our moderator, so we should be able to see him soon. Carlos, I'm going to ask you to turn off your camera, I think.
Yes.
In fact, I'll do that right now.
Yes.
And then Russell, we should have you joining us then. Now, it was actually great to see Carlos mentioning the droidCon Madrid app. In fact, I was just thinking about this, that we had what we like to think it was the first in 2018 at droidCon New York 2018, the first Kotlin multi-platform app that was in the iOS App Store and the Google Play Store. So that was actually.
I can't remember if that one or if the Kotlin Conf one was first, but it was very close.
We're going to claim it, and since this is a droidCon event, we're going to claim it. In fact, it was funny because I'm just going to show my screen really quick. This was actually kind of funny. Carlos mentioned that they don't like to have any mention of Android. This was the dog. So these were the two icons that were used on the store for the 2018 droidCon New York App Store. This fictional dog has now been replaced on all future versions with Kevin Galligan's actual dog. That is in the photo there. So yeah, Carlos is right. They don't typically like to have any mention of Android on the iOS store. But anyway, so we're going to claim it. But anyway, back to you here, Russell. I'm going to throw the screen sharing function your direction, so we should be able to see your slides here pretty quick. I'm going to pop off, and it's go time for you. Also, as mentioned, by the way, too, I mentioned I'd been to your session in 2018 that you did at droidCon here. How different do you think your talk is today from then?
Well, pretty different for two reasons. One, because things have changed much since then, and the other because that talk was focused on the library side of things, and this talk is focused on the application side of things.
Cool. All right. Well, good luck here. The time is now yours.
Alrighty. Thanks very much. So yeah, I'm Russell Wolf. I'm a multi-platform engineer at TouchLab. I joined TouchLab in this past February after having been doing multi-platform stuff for a little over 2 years. It's actually funny, Greg, you were talking about the like initial release of multi-platform in 2017. So that first release that was concurrent with Kotlin 1.2 was just JVM and JavaScript, because Kotlin native was still kind of in early development at that point. And it became possible to do, like, Kotlin native got added to multi-platform in February of 2018. And I was looking back at my Git history recently. And I guess I did my first, wrote my first code in, wrote my first Kotlin multi-platform code the day after that release. So I jumped in pretty early. So and that code was not quite yet the library they did, but one of my early projects that I still maintain was the multi-platform settings library. So yeah, that's a few notes about me. But let me get my thing working. Let's talk a little bit about Kotlin. So Carlos gave a pretty good kind of introduction to how Kotlin multi-platform works. So I don't want to repeat those details too much. But as a quick summary, so Kotlin multi-platform takes the different platforms of Kotlin and lets you compile platform agnostic code to multiple different targets. So that might be JVM, which is Android, or like server-side Java, JavaScript, which might be browser, or might be Node, or native, which might be desktop native, embedded, or iOS. And then you can use platform-specific code to talk to the APIs of those individual platforms. And like we're all very used to the smooth JVM interop that Kotlin has on the Java and the Android side. And you have similar interop with the platform APIs of whichever other platform you're running on from your platform code. And one thing I do want to note there, because I did see a question go by on it from the first talk. So you can do expect actual to talk between your comment and your platform code. And in a lot of cases, it can be nice, and it can do certain things that interfaces can't, like having expect constructors or expect top-level functions. But one of the disadvantages sometimes is expect actual is forced by the compiler to be a one-to-one relationship. So there is exactly one actual declaration per platform for each expect declaration. And one of the disadvantages sometimes of that is you can't swap that out for in your test code. So sometimes it can be nice to still stick to old-fashioned interfaces because it lets you like pass in a test mock instead. And yeah, the other point I want to make is Multiplatform is very well suited to mobile platforms in particular. So like yes, you can share between any of these different platforms that they provide. But one of the things that's nice about mobile is to your users, like Android and iOS are roughly the same thing. And like, yes, under the hood, they're doing lots of different things, but there's a lot of opportunities to share code between mobile Android and iOS apps because they're probably going to be doing the same thing because your users and like your project managers and such usually want them to be doing the same thing. And I'm not the only one saying this. Like Jeff Rains, when the last year's Kotlin Conf launched this like Kotlin for cross-platform mobile development page to signal like their interest also in pushing this use case as like one of the key use cases for multi-platform. And yeah, I really think it is the one of the best ones. But of course, like that's all I have to say. Like, how do you actually like get started with it? So yeah, Carlos gave us a great introduction. But one of the things that you can find if you've been kind of following the space for a while is like Kotlin multi-platform over the last 2 years has been a bit of a moving target. Like the best practices have evolved. The tooling has changed dramatically from what it was 2 years ago. And it's gotten a lot more stable recently than it was early on in terms of breaking changes and things happening. But there's still a lot of kind of old information out there that can get confusing. And then there's also the confusion of like what libraries exist. So Carlos was also talking in the first talk about like here are some of the kind of libraries that you've used to replace what you're used to on the JVM. And that's also kind of one of the early sticking points that a lot of people starting out have of like, yes, even though my Android code is kind of doing the same thing as it was doing natively, it's still talking to different libraries, and that still is a change that you have to get used to. And then of course there's all this new configuration stuff that you have to learn. So at TouchLab we kind of were thinking about all this stuff and kind of getting feedback about the difficulties that people are having. And that's what led us to put together the sample project called CampKit. And that is both it's a project template as well as a set of documentation so that you can have a source for like what is the kind of up-to-date best practice. And we're committed to keeping that up to date. So one of the advantages that we made with it is once you have kind of the build tools installed, like you have Xcode and Android Studio installed or IntelliJ, it pretty much runs out of the box, and that was important to us because one of the pieces of feedback we were getting was different teams would like set up a hack week and they wanted to investigate all the multi-platform, and they would spend the entire time just trying to get something running. And that means you have no time to actually like see how it works for a use case, and that would then cause people to dismiss it as not ready, even though if they'd kind of gotten over those source config hurdles, they might have actually been able to make a lot of progress. So we wanted to kind of help teams get over that hurdle more quickly. Here's what the template app looks like. It's a single screen. It's makes a web call to grab a list of dog breeds, and it lets you select which ones are your favorites. And in doing so, it runs through the whole kind of like basic stack that you might see in a typical CRUD app. So you make the web call, you say things to the database, and then you query that database to display the data in the UI. A couple of notes on the architecture of that. So the data layer is mostly shared. So that's the networking logic, the database logic, the kind of glue that holds everything together, and then kind of like the data that then gets exposed back out to the UI. The UI itself, it's two separate native UIs, and that lets you kind of continue to leverage your like native tooling expertise in kind of doing the top level build of that UI and of like working with the latest APIs that those platforms provide. And one of the kind of common themes in a lot of the decisions that we made in building CamKit was kind of making things play nicely with Kotlin native threading model. So you'll kind of see that as a bit of a theme as I walk through some of the code. So I'm not going to go super deep on the concurrency model. Kevin Gallagher has some great talks on it that I highly encourage you to check out. But the kind of short version of it is Kotlin native is much stricter about mutability and threads than you're used to on the JVM. So anything that is mutable can only live in a single thread and can only be accessed by a single thread. Something that is immutable can be shared across multiple threads. And immutable here does not mean val versus var or list versus mutable list or what you might be thinking of from what you're used to on JVM Kotlin. Immutable here means frozen, which is this new API that exists just in Kotlin native. That means that object and everything that it had a reference to can't be changed and will throw a runtime error if it does. What that ensures is that when you pass something across threads, it must be in the exact same state in every thread, and you can't get into these weird race conditions where you might get inconsistencies and hard to debug errors. So those rules are like simple to state. The implications kind of can take a little bit for you to fully kind of like grasp them as you're working with them, and they're a little different than what you're used to on the JVM, but it is very possible to work with them, and it can help you write better, like safer code. In particular, like it plays nice with architecture that kind of focuses on immutable data and kind of like a bit of a more functional style, which is a bit the way that the industry has been going lately anyway. So let's talk a bit about some of the libraries that exist in the KMP space and kind of how we're using them in CamKit. And I'll start with Kotlin Xcode routines. So coroutines are Kotlin's asynchrony library that you're probably used to coming from the Android world. And there's kind of two major APIs that we make use of in GANKit. There's like using suspend functions where you're just kind of like suspending and waiting for a single value, and there's flows where you're listening to a string of values. And these, of course, so you can use these in your, you can use any of these APIs in your Kotlin code on iOS, but suspend functions don't get exposed to Swift, so you can't use it from like your UI level code on iOS. So the way to work around that is you can kind of manually pass some sort of Lambda callback. And in Kotlin 1.4, there will be a kind of thing that generates that automatically, so that you don't have to set that up manually yourself. And another kind of important piece of what we're doing in GANKit is coroutines in Kotlin native, the release version are single threaded, which in practice often means main threaded, but you can be single threaded on a background thread as well. And that obviously has some limitations. So there's a preview release of multi-threaded coroutines that hasn't been merged into the main trunk yet, because there's some issues that they're still working on in terms of memory leaks that can happen. But GANKit, which is trying to be like mostly state of the art, but a little bit forward looking, makes use of that multi-threaded branch to kind of get you started writing code with it, in the hopes that like by the time that code hits production, that will all be stable. And another kind of note around our coroutines usage in GANKit, we're expecting to do some refactors at some point in the near future around how we handle coroutine scopes. So like right now, the shared code is creating its own scopes, and we'd like to adjust that so that, at least on the Android side, the Android code can pass in things like the model scope that you get natively in Android. So if you're looking at the code today, like expect some changes there at some point in the future. So moving on from coroutines, the dependency injector that we use in GANKit is Coin, or I should say the dependency manager, so that I don't step into the middle of that like dependency injection versus service locator debate. We're using again, this is a preview of the next version of Coin. It's an alpha of Coin 3.0. And it's what that adds, and this was contributed by Kevin again, is it basically adds some thread safety by kind of enforcing that the configuration of Coin happens on the main thread on iOS, so that you're not accidentally passing some things across threads. And within our usage of it in GANKit, we have kind of a couple different integration points across common and platform codes. You can within Coin, you can kind of inject dependencies at different levels. So we have the core module, what you see in the middle here, that passes dependencies that kind of only need to be configured from common. We also have a expected platform module, which lets the common code, or let's say lets the platform code pass in kind of platform specific dependencies that Coin needs to have access to. And then we also have this extra app declaration lambda, which lets not just the platform code of the shared library, but also the like top level application pass dependencies in, and that lets us insert the Android's application context into the Coin graph. And then, yeah, one other point I want to make about Coin is there's a test API that they expose, which we have a testing campaign that demonstrates, called check modules, which provides kind of the same sort of graph checking that you get in something like Dagger at compile time, but it runs at unit test time instead. So if you're concerned about moving from something that's kind of compile time checking your graph to something that's runtime checking it, having something like that in place can still help you kind of feel confident that your graph is staying consistent. So KTOR is the cross-platform HTTP client that JetBrains provides, yeah, so it's a coroutine-aware HTTP client. Sorry, I just did the code. That animation went in the wrong order. So it does its JSON conversion via the Kotlin serialization library, which I won't go into more detail on because we don't actually do anything specific with it other than kind of using it as a backbone there. So KTOR right now is not multi-thread safe in that it's built against the release version of coroutines and doesn't work very well if you kind of call it from different threads. So we have this this workaround kind of buried in GamKit, which is this network lambda that you can see on the right there. That basically kind of forces the KTOR calls to happen from the main thread so that KTOR can handle its own threading internally in the way that it's expecting. So hopefully that goes away over time, but it's not stopping you from using this stuff right now if you're configured correctly. SQLite, we already heard about it as well earlier today, but it is the cross-platform or multi-platform database library. So what's neat about it compared to something like Room is it generates its models and queries from SQL statements. So what you see on the right here is like the code that you write is just the create table statement, and the like the data class to implement that is then like auto-generated by SQLite. So that it's kind of like the inverse of what Room does, where Room you define your entities in your DAO objects, and then you have to like annotate them with SQL events to match. SQLite kind of does the opposite and says like just start from the SQL, and then you'll you can generate the Kotlin code that's correct without needing to manually match it up yourself. And then it has platform-specific runtimes. So you kind of pass a separate, I'm forgetting the word they use, but you have a separate engine to it from Android and from iOS that is actually running the queries. Another thing we have in here is multi-platform settings. So that's my library. So it's key value store. So SQLite is your like complicated structured data storage. Multi-platform settings is your, I just have like one or two little name values, like a timestamp or a user ID or something that I want saved. Also has some update listener APIs, which are not currently used in GamKit. So yeah, I won't say too much about it because despite it being my thing, and you can hear me talk about it in some of my other talks, it doesn't play a huge role on the GamKit side. But yeah, similar to SQLite, you pass in a platform-specific delegate that's kind of what's actually driving the backend storage, and that lets you share that backend storage from your shared code and your platform code. Stately is a library from TouchLab that's focused on various parts of concurrency management. Part of what it does is it adds kind of common definitions of the different Kotlin native freeze APIs so that you can call those from common and not just from your native code. In a starter module, it also kind of adds some different threading primitives. So this sample code on the right is using Stately's guarded stable ref, which essentially like enforces that the reference that it contains is only accessed from a single thread. And that's part of the internals of that network call that we use to work around KTOR. And then another thing it has that's not currently in GamKit, but is kind of worth discussing is this module called isostate. that essentially lets you handle state in a multi-threaded context by kind of having a single thread that your immutable state lives on, and then it provides you APIs to kind of go in and talk to that state while handling the threading for you. So there's a collections or some collections implemented on top of that are much more performant than the kind of older stately collections that were all based on atomics and did a lot of kind of blocking because of that. Last thing I'll go through quickly is Permit, which is a logging library that we've recently been putting together at TouchLab. And it's the kind of key piece of it is it's immutable after, like, your logging configuration is immutable after you first configured it, which then makes it safe to pass between threads. So it's not yet merged into CampKit. There's a PR open right now, so you'll see it there soon. Yeah, we're interested to hear feedback if it is or it isn't hitting your use cases. So that's much libraries. I'll also talk a little bit about just some other notes on configuration. There's a bunch of kind of like new Gradle things that get added when you go from Kotlin JVM to Kotlin Multiplatform. And from like we have them all kind of set up for you initially, but we can talk about kind of what some of it is. So the big thing is like the way that you set up your dependencies changes because you have to specify all your different targets. So within your Kotlin block, or you have a Kotlin block now within which you call these different target functions. So like this Android function or the iOS ARM64, iOS x64, and that tells the build system like these are the platforms that my code is going to build to, and then that will generate main and test source sets for each of those targets, which you could then kind of separately configure dependencies for. A lot of dependencies these days are being published with Gradle metadata, which means you can kind of just set them from your common main, and Gradle will figure out how to kind of put the right platform-specific dependencies in place. But certain things like the standard library, you still have to specify for each platform. Another small note here is there is a helper function called iOS that essentially does what this block here on the right is doing of checking whether you're using the simulator or using an actual device on iOS. And it sets an intermediate source set kind of between them. And it doesn't always play nicely with the IDE, especially with Android Studio. So you might see that in some other examples, but we tend to recommend like sticking with the manual configuration for now until the IDE side and the kind of inference side gets cleaned up. Another thing you might be noticing here is we're using Kotlin build scripts. I tend to find like it takes a little bit of getting used to moving from Gradle to Kotlin in your build scripts, but it's really nice kind of having some autocomplete and being able to, especially with the kind of new Gradle APIs that are involved on the multi-platform side, it's nice having some autocomplete to be able to make things a bit more discoverable. And then we have some configuration to opt into generics on the Objective-C side, which in Kotlin 1.3x aren't automatically forwarded to, like, generics in Kotlin are automatically forwarded to Objective-C and Swift in Kotlin 1.3, but it will be in 1.4. And then we opted into the experimental coroutines API because we were using them in a bunch of places. Another thing we have in there on the Gradle side is we have a version of the CocoaPods Gradle plugin. So this is a fork of the official JetBrains plugin. So generally the philosophy around CocoaPods is it uses a bunch of the iOS integration configuration. So without that, you kind of have to manually set up your frameworks and like set up a Gradle task to copy that framework over to Xcode. And there's like 2 different ways that you could do it that were in different samples for a long time. Like CocoaPods kind of helps handle that all kind of more seamlessly under the hood. Unfortunately, the JetBrains plugin is not, you can't really configure the framework that it generates. So one of the things that we wanted as we were building up CampKit was the ability to debug things in Xcode, and to do that, you need to have a dynamic framework instead of a static framework, which the default CocoaPods plugin didn't allow for. And so what we've added is the ability to kind of specify the frameworks block within the CocoaPods extension, so that you can, so that whatever configuration you want to add, you can pass in there. So yeah, we like generally expanded configurability, and also some adjustments in how the pod file is generated, which helps deal with some caching issues that can cause you issues when you're like trying to make sure you're getting a clean build. And yeah, that's still in, like, we're still kind of actively developing that and kind of like figuring out what other things we can do to do with it to kind of help the development flow. So let us know if you have use cases. Then a little more on the Xcode side. TuxBot has a debugging plugin for Xcode, so you can debug your Kotlin code. You can debug, like, step into your Kotlin code from the Xcode debugger. And CampKit is set up so that the Kotlin sources are already in the Xcode project, so you can like immediately like jump to the right source. But you do have to like install that plugin yourself on the Xcode side. So I'm a little short on time, but in the time I have remaining, I'll talk a quick bit about a couple kind of things that we've built on top of this. Which one is less interesting. So in general, CampKit has been really nice for letting us, like, not just for kind of like showing people like, here's the way you can get started quickly, but also for us to kind of prototype things quickly. So one of the ones that I did recently that I want to do a blog post and go into more detail on at some point soon, but I've seen it asked in Slack a couple times lately, is around interop between RxSwift and coroutines. So this is a thing I put together that kind of like roughly does that, where you can, so the generic memory of flow doesn't get exposed to Objective-C because flow is interface and Objective-C generics only work on classes. But if you add a wrapper class around it, you can kind of maintain that type safety and pass it up to the Swift side, and then you can add this extra kind of observable generic function on the Swift side, which lets you as you kind of like pass the different callbacks that flow is looking for, and hook them into the RxSwift observable. So this isn't perfectly thread safe as written if you're doing a bunch of threading things on your RxSwift side, but it's kind of like a start of how to make them talk to each other. And of course, we've also like built some production code with this. So we had a client that was having us kind of like prototype, like, what does a feature module look like in our existing app, and we were able to use CampKit as kind of the starting point for that configuration. So we had to kind of like make some changes to plug it into the client's build system, and in particular, like their iOS code lived in a different repository than their Android code. So we did a bunch of work around kind of being able to toggle between building the shared framework from source, or just like referencing it as binary. And it's been nice kind of like working with clients and being able to kind of go back and update CampKit with the learnings that we've had from using similar configurations in production. So I think I'm a minute or two over, but a couple of just kind of like quick final thoughts. So like the general nice thing about Kotlin multi-platform is you have a lot of flexibility. So I've talked a lot about libraries in here and local configuration things, but depending on what you want to share, like if you just have kind of like a pure business logic thing, you don't need to use any of that if you don't want to try out any of that new stuff. Like if you just want to write pure Kotlin code, you can do that and share it fairly easily. I also want to definitely emphasize like this, like I'm a huge proponent of this stuff, and I definitely think it's kind of the future of how a lot of us will be building mobile apps. But it's definitely in the early adopter phase now, and you should make sure you're kind of like comfortable buying into that. So like there were some questions earlier around like, is it production ready? And I think what production ready means is different to each team in each organization. So there are teams using it in production now because to them it is production ready. Your opinion of that will vary depending on kind of like your needs. But it's definitely at a phase where it makes a lot of sense to evaluate it and see if it is over that line for you. So yeah, I think with that, I will pass things over to questions.
Nice job. Thanks so much, Russell. Fantastic here. So we're going to get the questions going pretty quick. Before I do that here, I've got to give you the, you know, we're going to stream in our live audience here so that they can. Yeah, that was it. Great job. Okay, so I'm going to have Uli bring up our questions here, and his screen should be sharing with us at this point here. So you should see the questions from Slido coming up on your screen. I'm going to pop out for this.
Sure. All right, so at the top we have what is the best CI/CD workflow to share a multi-platform lib inside a mobile team, like single repo or a shared lib. I think that is a thing that will vary by team. Like one of the nice things about kind of the modularity of Kotlin multi-platform is you can kind of continue to lean on the same like build pipelines and stuff that you already are in your native code as you're trying to introduce it. So like the new piece is now you have the shared library that you're going to want to like build and test. And if you're in different separate repos, you'll need to kind of like publish the autograph for it. If you're in the same repo, you can kind of test them all at once. I don't know that I can like, yeah, I don't know that I want to point to kind of like a single best workflow. I think you can kind of like make that choice depending on what your needs are and on like maybe how much code you're sharing and how much you need to test the library in isolation versus kind of all together. So do you find it beneficial or detrimental that KMP doesn't include shared UI? I wouldn't say, I certainly don't find it detrimental. I think it's like, KMP is trying to do a different thing than Flutter is. Like Flutter is trying to be shared UI and maybe kind of like skips over the details of some of the stuff that happens under the hood. KMP is about kind of working at that lower level, sharing things that are kind of like more at the logic layer and less physically tied to the platform. So I think that means that KMP is a lot more flexible. So like Flutter is going to have a pretty big impact on the architecture and the build process of your whole application if you're using it. KMP you can kind of like slot in wherever you want, and it can be as much or as little as you want, and you're not paying a huge penalty for even if you're just using it a little bit. Any tips on improving build times? Certainly is something that we're doing some thinking about, and it is something that like JetBrains has been improving over time. So like if you tried this stuff like 6 months ago, it definitely does build faster than it did then. Off the top of my head, I don't have kind of like specific tips. But like, I mean, modularizing always helps if you're doing something large scale. Like any way that you can kind of not need to rebuild your Kotlin native code will help. How do you get around the Kotlin native closed world principle? You get around the native closed work principle, e.g. writing iOS UI classes in KMP and using index code or calling subclasses in Objective-C not being exposed properly. So this is basically talking about there's some limitations around in the internet around the fact that you can't kind of go back and forth multiple times between Kotlin and Objective-C, and you like each Kotlin or each binary that you like each framework that you create out of your Kotlin code kind of doesn't know about the others. And the way to get around it is, I mean, the easiest way to get around it, if you can, is to kind of do more things at the Kotlin level. Because like if you're kind of like just in the Kotlin world, then you don't have as much of those limitations. And if you're not able to do that, then it's just about kind of like segregating things such that you don't have too many interdependencies between your modules. So like if you have multiple frameworks, making sure that they do independent enough things that they don't need to talk to the same stuff under the hood, so that you don't have to worry about kind of which version of Kotlin they are under the hood. So hopefully that sort of also answers the next question of what is your experiences with dependencies between two libraries. So it is like it's possible to have multiple Kotlin libraries in your framework as of 1.370. We've been doing some kind of testing of some limitations of that, and some blogging about that, I think. But so it's possible to have two. You can't, like, they won't be aware of, you can't really like pass Kotlin types between them. So if they have interdependencies between them, again, you'll want to do that more at the Kotlin layer than at the Swift or Objective-C layer. Do I know any framework for common UI? So there's a couple people that have done like some things. There's nothing that seems to have really caught on very largely in the community. I tend to think it's like, it tends to not be my focus. And I tend to think it's a little bit kind of early to be too focused on the UI side of things. Like where Kotlin really shines is more at the logic layer. And you'll have a easier time working with it if you can kind of get into the mindset of, I'm not going to share every piece of code, but I'm going to share the things that make sense to share. What are the pros and cons of different ways of defining dependencies? Mostly it's stylistic. Doing that, like, and I've done both in different projects. One of the like slightly annoying things of the like by getting style is you get all of these like unused references. Like unused reference warnings, which you don't get in the source bracketed version. But ultimately, doesn't really make a big difference. It's doing the same thing under the hood. In order to share code with the backend, any tips about how to import a library written with KMP from a backend written in JS? So I personally haven't done a ton on the JS side. So like I have a JS target in multi-platform settings, and I've like have a Hello World project that builds a JS browser target. But I haven't. I'm not very familiar with kind of like the more like the deeper side of JS configuration. So I definitely recommend asking about that stuff on Slack though, and if you haven't looked at JS in a little while, there were some pretty heavy refactors to kind of how it's configured in it's a while ago now, like a year or so ago now in Kotlin 1.340, and the documentation has gotten a lot better on that in the last couple months. So if you haven't looked closely at it recently, definitely take another look and see if that helps. What is the difference between immutability and freeze? So in the language that I was using when I was talking about freeze, they are the same thing. So like when you call freeze on an object, or when an object is frozen, its immutability is like it is enforced as being immutable. Probably off topic, what kind of moves is TouchLab making towards desktop app support? None that I have been a part of. Though like it's something that we pay some attention to on the library side. Like it's easy to expose a target to a desktop platform from a library that we're building. Like we'll do that, but we're like the clients that we're talking to are much more on the mobile side. How is the performance of isostate? Any suggestions, best practice to handle the shared cache with good performance? So for that, I'd refer you back to Kevin's blog post where he talks about it. It's much better than what you had with atomics in the first state of the collections. It's not going to be quite as good as what you get with just a single threaded thing. But that's kind of the trade-off that you're making by having state that you want to access from multiple threads. How do you decide which libraries to include in CamKit? Largely by the ones that we want to be using in the apps that we're building, and the ones that kind of like work well in the situation that we've encountered, and that we kind of like trust to keep updated. When do you decide that this logic part won't be shared? I'm not sure I understand specifically which logic part that is, but in general, like you can make that sort of decision and even change it over time. Like if you're trying to figure out like what do and don't you want to share within an existing code base, you can kind of like pick an area that seems to make sense to start off and add more to it over time. It's not kind of like a permanent thing. Do you know if there's a clean way to share test artifacts between two MVP modules? So the one way that I've done it, and you can see this in multi-platform settings, if you look at the configuration in there, is create a separate module and define those test artifacts in that module's main code, and then you can depend on that module from your test code. So it takes a bit of configuration, but it's doable.
Well, great, Russell. Looks like we were able to make it through all the questions. Thank you. So, we've got one more that popped in. We'll give you a couple seconds to answer that one as well.
Sure. Yeah. What is the best architecture to use in KMP? Also, what is the best way to maintain checkpoint compose states in KMP? So I'd say in general, like KMP is unopinionated on your architecture. Like I tend to find it works a little nicer with like MVVM and MVI stuff than it does with MVP, because you might be kind of moving back and forth between your platform and your shared code, but ultimately even that is not a huge deal. As far as Jedi Compose stuff, I don't have a great answer for that, other than that, like most of the things that you would probably have at the compose level are going to be at your UI layer, which is probably your platform specific layer. So assuming that is correct, you're just going to kind of leave it in your platform code anyway.
Nice. Well, thanks so much. This has been fantastic to have you, Russell. Also, Carlos, thank you for being with us. Again, this was our first installment of the multi-platform series, so we expect to go deeper. I know there were some questions, differences with respect to Flutter and multi-platform, so we'll be covering some of those as well in a future event. So anyway, really been great to have you all. Thanks for everybody who signed in to this as well. It was great having you here with us. And again, check back regularly at droidcon.com, and you'll be able to see what's coming up next. You'll also be able to get all of the presentations there probably within the next day or so. And we look forward to seeing you again at further series here at droidCon Online. Thanks so much again for being with us, and we'll see you next time.